So in this slide, we will cover the various data architectural considerations when formulating a cloud solution system. While we can use the data architecture framework to understand the various architectural decisions at a higher level, a number of underlying and low-level decisions are also needed when creating a data architecture for a cloud solution. So similar to what we had done in the application architecture chapter, here we'll cover the key drivers and some of those architectural questions and factors that come into play related to formulating a data architecture of a cloud solution. The architectural drivers for a database architecture are quite similar to that of the application architecture in that the data architectural consideration depends on the business requirements and the overall enterprise architecture of the organization. Keeping those in perspective, the additional factors that can influence the data architecture of a specific cloud and digital solutions include the following. Data volume. One of the key considerations that an architect needs to focus on is the volume of data that will be handled by the application. Understanding the data volume can help the designers and architects of the system to make a number of other decisions, which can include, but are not limited to, performance, amount of storage required, computing capacity requirements, and other such decisions. This can also help the solutions architect to get a better understanding of data growth, because data is known to sometimes grow at an exponential rate, depending on the specific use cases. In summary, a solutions architect needs to perform comprehensive assessments related to data volumes related to the system. Complexity of applications and/or transactions. The complexity of the applications and the business processes that they enable have a profound impact on the overall data architecture of the solution or organization. Obviously, the more complex the applications, the more tasks that would be involved in data capture, processing of data, storage of data, and so on. The solutions architect, therefore, should unpack the overall solution complexity down at a business process and at a transaction level to be able to create a proper data architecture for the solution. As we reviewed earlier, solutions architects need to understand the various types of databases that will be used in the system before databases can be selected. A common question is whether the data capture can be organized in a structured way, or will it also include data from semi-structured and unstructured sources. So as we had discussed earlier, the choice of specific databases depends on the types of data that are used in the overall solution, the business use cases that they serve, and the application technologies which are used. Enterprises, for example, can choose between an Oracle SQL or a Hadoop database for a data warehousing solution, depending on the data and the business use cases. Each solution, therefore, has its pros and cons, and CIOs and solutions architects have to evaluate their business architectures to determine the best databases which are needed and the solutions that are going to fit around those databases. Storage latency is an important factor when establishing a database architecture. To ensure transaction reliability and performance, one needs to select and design storage architecture in a way which doesn't slow down the applications. A database security is another important domain, whose scope can become quite large depending on the cloud system, the number of databases involved, how the data is captured, where the data is hosted and stored, etc. Database security issues touch upon decisions related to which data needs encryption, how data access needs to be controlled for authorized applications and users, encrypting data transmission, employing different authentication mechanisms, how data is to be provided for developing and testing without exposing sensitive data, and so on. As we had covered in the application architecture chapter, the system-level security issues are also driven by an organization's security policy. A solutions architect's job, therefore, is to consider all these factors in the security architecture of the cloud solution. We will cover more about cloud security architecture issues later in this course. Data migration is a key function involved in the implementation of most cloud solutions. Data is either migrated from internal systems to new destination databases, which will be the foundation for the new cloud systems or legacy data, or legacy data can be moved to the cloud to help the new cloud applications access that data on the cloud. There are other cases as well, but the key point here is that data migration should be a key consideration when planning for a data architecture exercise. Planning for data migration by itself necessitates a number of questions, which include how data will be imported, cleansed, etc., before making the new destination databases ready. Database instances refer to the multiple instances that an organization creates to support the overall system's development lifecycle from development to production deployment and going live. As the development and testing of the application requires a lot of data movement and ensuring that all teams have the right data to perform their tasks, planning for different data instances can become a major activity for solutions architects. For example, the team may decide to have cloud-based database instances to perform development and testing before they decide to go live with the data and databases located on premises. However, in these situations, moving test data to a cloud would need to be handled very carefully to ensure that sensitive data is not exposed and that the security of the organization is not compromised. The bottom line is that solutions architects need to carefully plan for all database instances during development and testing, and also planning how it will work in a production environment. As applications are usually distributed, solutions architects need to plan and think about how the databases will be distributed, and especially if they will be located in multiple cloud availability zones. These questions and their answers can influence the design of databases, data migration issues, data security issues, and others. As we had covered earlier, most solutions requires a lot of data processing. This processing can happen either in a batch or real-time environment. So the questions that an architect needs to ask in creating data architecture is the extent to which the data will be processed in batch or real-time. These questions and decisions then can influence the overall performance requirements of the solution. As we can imagine, that batch processing, which is processing in an offline mode, may have less performance requirements than the real-time scenarios. This therefore can impact the level of computing resources that are required. So more computing resources and additional planning is probably needed to process and analyze data in real time. The choice of the type of processing depends on the business use cases and requirements. As an example, live streaming production data from a manufacturing plant may need to be processed and analyzed in real time to ensure that there are no interruptions in ongoing production, whereas a payroll processing application to determine next month's salaries for employees can be run over a few days in an offline mode. A data query tools refers to the types of tools that are made available to the end users to process and analyze an organization's data. If a lot of users are provided read access to an organization's operational data stores, then that can slow down the applications accessing the same databases. So the solutions architects need to consider this when finalizing the overall data architecture. Data analytics and AI and machine learning requirements. As we had covered earlier, the data architecture of the organization includes both analytics and operational data. The solutions architect therefore should answer questions related to both aspects and how requirements related to both will be met. An organization, for example, may have various data analytics related requirements from providing users with basic data query tools to preparing data for advanced AI and machine learning processing. With the need for analytics and AI ML processing increasing by the day, solutions architects should understand these requirements as they impact the overall data architecture related to the cloud solution. Data pipelines. Earlier we had discussed how establishing a data ingestion pipeline is essential to capturing data from various sources and loading that data into destination databases. In a typical cloud solution, a solutions architect may be faced to establish multiple data pipelines responsible to take data from various sources to different destinations depending on the business use cases. So the data ingestion pipelines could be established to process data in real time, running advanced analytics, sending data for storage, splitting data between real-time and batch processing, and so on. Planning for these data pipelines, therefore, is a critical part of the overall data architecture exercise. Data replication is about storing data in more than one location. Data replication has many advantages and business uses. First, by having data in multiple instances, an organization makes that data available to a larger user base without making one database the bottleneck. Also, data replication is used as part of the overall system availability strategy. So if one database goes down, another replicator database can be brought online. Database performance. One of the goals to keep in mind when finalizing the data architecture is to ensure that all the physical implementations of databases and related processes perform at the highest level. Database performance can have a tremendous impact on the overall performance of the system and of the overall business. That's why it's quite important to design a high-functioning database architecture. The goal is to improve the database performance, to improve throughput and minimize contention, and be able to support complex transactions and large and parallel workloads. A number of steps are required in tuning database performance. These can include optimizing queries, improving indexing, which is about how a database structure is organized, defragmenting data, which brings similar groups of data together so it can be accessed easily, having the right CPU and memory sizing for the solution to handle the data, and so on. An architect's job, therefore, is to ensure that all database performance factors are considered when finalizing the data architecture of a solution. Reducing total cost of ownership. The data architecture of a specific solution leads to decisions related to the number of operational databases, database instances, number of places where data may need to be hosted, cloud-related database hosting, the amount of storage that's needed, and so on. It's quite clear, therefore, that the resultant data architecture can have a direct impact on the overall cost of the solution. The solutions architect, therefore, needs to ensure that the overall TCO, or total cost of ownership, is minimized while meeting the overall business and technical requirements. So these were some of the considerations in finalizing a solution's data architecture. And again, these may change depending on the business use cases, the business requirements, and other dimensions of the enterprise architecture. An architect needs to ensure that such factors are considered when finalizing the data architecture of a solution.